This video will help you to complete the questions on homework 21. In the first section, it says to simplify each expression and write using positive exponents. And so therefore, it's not asking us to compute any of the actual math if the numbers are bases. So for our first question here, we have some rules that we need to follow in the numerator, and then we have a second operation here of dividing like bases. So it looks like our numerator, we will keep the base of 4, and we will add the powers together to get -8. Then when we divide by 4 to the -2 power, we will keep the base the same, and we will subtract the powers. -8 minus -2. That gives us a -6. Now remember, your powers need to be positive, so we're going to take the reciprocal, and that's how my power becomes positive. Letter B. Dividing like bases, you keep the base the same and subtract the powers. Remember, 8 minus a -3. 8 minus a -3 has 2 subtraction signs in a row. So therefore, we actually are going to add the opposite, right? So 8 subtract a -3 is going to give us a +11. For question C, there are no operations to follow, but to make the power positive, we need to take the reciprocal. For question 2, I'm going to keep the base the same. 6 divided by 6, we'll keep it as 6, and 3 subtract 5 is -2. We're going to take the reciprocal and make the power positive. For letter B, this power is going to distribute to both of the powers inside the parentheses, giving us 3 to the 4th and a to the 12th. Remember, when you multiply each of these powers, right, that's the result. I could compute 3 to the 4th, but it does say to write using positive exponents, so I'll leave it like this. Question C, h to the 11th. When you multiply like bases, leave the base the same and add the two powers together. To convert a number into standard notation, you need to look carefully at the power of 10. If the power of 10 is positive, your number will get larger. If the power of 10 is negative, your number will get smaller. So for question 3, we're going to move our decimal 4 places larger, +4. So if the decimal point is between the 3 and the 2, we're going to move it 1, 2, 3, 4 places larger, because that's what 10 to the 4th power does. Remember, any space here that you've moved the decimal that does not have a digit gets a placeholder 0. So the answer to question 3 is 3, 2, 0, 0, 0. Place your comma, and now you're done. Remember, the power of 10 tells you how many times to move the decimal point, not how many zeros your answer will have. For letter B, the coefficient is 2.7, and the power of 10 is -4. Now, negative powers mean your number will be smaller. So when I start with my coefficient, the decimal here is between the 2 and the 7, but I need to move 4 places lower. 2, 3, 4. And this time I have to write the decimal point. Before, the decimal point was all the way at the end of the number, so it was optional. But when the decimal point is at the beginning of the number, you must write it. For question 4, we need to convert our number back into scientific notation. I think I accidentally put this decimal point here Let me just shade it out for a second. It's not supposed to be there. Okay, there we go. That's how the number should look. The spacing is a little awkward. That's where I want the decimal point to go, not where it started. So a number in scientific notation has to have a coefficient, right, a front number that is between 1 and 10. So if the decimal point is far to the left, we move it all the way in between the first two non-zero digits. And depending on how far you move it, that will determine your power of 10. I moved 1, 2, 3, 4 places. And because my number was smaller than 1, my answer needs to be negative, right? If you start with a small number, which we did, your power will be negative. If you start with a large number, like in letter B, your power will be positive, right? So I know I'm going to have a positive power of 10 over here. The question is, what will that power of 10 be? Well, I don't see a decimal point, so it must be hiding here at the end. I want the decimal to be between the first two non-zero digits. So 5.74. Now I have to choose my power. The power is determined by telling how many place values you moved that decimal. Well, I moved 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So my power here is going to be 9. Remember, the power is positive because I started with a number that was larger than 1. All right, let's take a look at the second section. The second section asks you to simplify each expression. So be careful where your negative signs are, where your powers are, and how you're using them. Letter A and B are similar in how they look because they both seem to have a -9. But where the parentheses are determines whether the negative sign is used in your repeated multiplication or not. This example A is a negative sign and 9 to the second power, which is -81. But in letter B, we have this group -9 to the second power, which gives us a +81. And then in our third example, 9 to the 0 power, well, anything raised to the 0 power is equal to just 1. Number 6, is the following number written in scientific notation? Explain. So it looks like it has all the parts. It has a coefficient, has a time sign, has a 10, has a power. But unfortunately, there's something going wrong here. So the answer is no. The following number is not written in scientific notation, and now I'm going to explain why. No, this number is not written in scientific notation because the coefficient, remember the coefficient is the number that is multiplying the power of 10. So, no, it is not in scientific notation because the coefficient is not written as a number between 1 and 10. So that's the actual mathematical definition instead of writing it in English, right? The coefficient needs to be a number that can be equal to 1. That's what this means here. You can be equal to the number 1, but you have to be lower than 10, right? You have to be a single-digit value. Question number 7. What is the solution to 4 times the quantity x plus 2 is equal to 4x plus 2? Well, when I distribute here, I get 4x plus 8. And on the right-hand side, I have 4x plus 2. So I can actually see the answer already. When your coefficients and variables match on the left and the right side, but the two constants don't, that's an impossible situation. But just to prove it, let's try subtracting 4x from both sides. See, we get a double elimination. And when the variable disappears, if the sentence is not true, then there is no solution. There is no solution. Well, let's take a look at the back side. Sharon solved the following problem incorrectly. Explain in words the error she made and show the correct solution. Alright, well, we're multiplying like bases here. And when you multiply like bases, you keep the base the same and you add the exponents. So let's keep the base the same and add the exponents. So it looks like Sharon got the right power, but not the right base. So explain in words the error she made. Well, I've already corrected it here, so now I just need to explain. Sharon multiplied the bases when she should have kept it a 3. Question number 9. Which of the following graphs shown is not a function? Well, in order to be a function, you have to do one thing. Pass the vertical line test. If you pass the vertical line test, you're a function. If you fail the vertical line test, you are not a function. So here's my vertical line right here. I have a red line on the left side, and I'm just going to scan it across my graph. Remember, if you touch the graph more than once, then you're not a function. You fail the vertical line test. Well, letter A is a pass. Letter B is also a pass. Letter C is also a pass. But letter D fails several times. See? I'm touching the graph in more than one location. I'm touching it here and here at the same time. So letter D is not a function. In the last section here, we're going to review some old concepts. Number 10, dividing like bases means you keep the base the same and subtract the powers. Be careful here, 9 minus a minus 3. When you have two minuses in a row, you add the opposite. 8 to the 12th power. For question number 11, we're multiplying scientific numbers. So remember, when you're multiplying scientific numbers, you multiply the coefficient times the coefficient. So 4.8 times 2.1 is 10.08. And then you add the powers of 10. And 8 plus negative 3 is 5. The last step is to double check your coefficient. Make sure it is a single digit number lower than 10. Ours is not. So we need to move the decimal for the coefficient one place lower and the power of 10 one place higher. The final answer is 1.008 times 10 to the 6th. Remember, if you're moving a place value less for the coefficient and you're moving a place value higher for the power of 10, you're not changing the number at all. These two are inverses. So I'm writing it in a different way, but I'm not changing its value. Number 12. Standard form means to perform the operation of the power of 10. So I need to be 4 place values smaller. So if my coefficient is 2.4, I move 4 places smaller. Not add 4 zeros, just 4 places smaller. So remember that 2 takes up one of the places. So these other 3 will be filled with zeros. Last 2. Number 13, which equation does not represent a linear function? Right, so no powers, no products of variables, and no variables in the denominator. Right? Those are our notes. Looks like letter A is the rule breaker right there. It has a power of 3 on a variable, so that is not a linear function. Y equals mx plus b, y equals mx plus b. This one is not in the right order, but it can be written as y equals mx plus b. Question 14. Explain in words how to find the solution to w to the 8th divided by w to the 4th. Keep the base the same. Subtract the powers. That's it. Those are the directions on how to divide like bases. If it also wants the answer, you write w to the 8 minus 4. That concludes our video on homework number 21.